Hello, good morning, my dear Tinkers. This is your Tinker Master Srinivas from scientificstudents.com. I greet you all on this 11th May 2026, celebrating National Technology Day. So, on this National Technology Day, I am sitting with my young Tinkers, my young mentees, most inspiring mentees. I am going to show you through a pic by editing that pic into this video, because at this point of time I can't take this phone and show them. So I have fixed this phone now. But anyway, today I am going to explain them what is the voltage across LED, what is the current pulled by that LED. That is what I am going to mentor them. So this is, you all know that it's a basic circuit. So 9-volt battery is there, and the positive is there and negative is there, and the positive is going to the switch, and from the switch it is coming back to the breadboard. You can see I am going to switch it off and switch it on also. You see, when I switch it off and the current is 0 and the voltage across the LED is 0, because this basic circuit is not powered. So I am going to switch it on now. You see now. So the 9-volt went into the switch and it returned back, and then it is going to the resistor, and from the resistor it is going to the anode of the LED, and the cathode of the LED, it is not directly getting grounded, not directly getting connected negative of the battery, because I wanted to show you the current, how much current the LED presently pulling because of the value of the resistor what we have used here. It is 470 ohms at this point of time. So 9 volt influenced by the 470, the current required for the LED is 15 milliampere. If you wanted to allow more current, then you have to decrease the value of it. Maybe 390, 360, 330, 270, 220. You can experience that by changing this resistor and see the current how it increases, and at what resistance, at what current that LED will go bad. That is one point. Second point is, I have a small little mentee, his name is Arush. So Arush told me, say if I increase the value of the resistor and then it will go, what Arush, what happens if I increase the value of the resistor, what happens to the lighting of this LED?
It will be dim.
It will be dim, that's what he said, okay. But that is generic answer. So we wanted to know at what increase of the resistor. Now it is 470, if I go 560, or 680 or 1001 kilo or 1.2 kilo or 1.5k or 1.8k or 2k or 2.2k or 2.7k or 3k3, 3k6. Likewise, if I increase the values, and at what value the resistor will be so much dim and finally it stops glowing. That's another STEM exercise I am going to give for my mentees today. You can also experience the same thing. Now you understood, my dear children. So this is the basic circuit which we always draw on a board, like it is called a kind of a schematic drawing, and 9-volt battery positive to the switch, and then the resistor, and then the anode of the LED, and cathode back to the negative. Switch is on, the circuit is closed. This is the current. It is measured, so 50 milliampere. This is the voltage. Now another most interesting point I am going to share with you all, the voltage across the LED. Voltage across the battery is 9 volt, which I have already seen earlier, but now voltage across the LED, because the resistance, how much voltage it is dropping. So voltage across the battery minus the drop of the resistor is going to be the present across the LED. That we have seen 2 volts. That's what this meter is showing you now. The connections I have inserted in that way. So now you need to understand. So battery, the LED is designed and made and manufactured for that voltage. So we are allowing near about 15 milliampere to maximum of 20 milliampere by adjusting the proper value of the resistance. So now another most interesting case here, if I use here only 3 volt, then definitely this resistance will be high because the pressure is low. So at that time I need to make sure the same 15 milliampere and the same brightness, what you need to do is you have to decrease or increase the resistance. For 3 volt battery, to maintain the same 2 volts and the same brightness, do I need to increase the value of the resistor or decrease the value of the resistor? Not for the 9 volt battery, for 3 volt battery. Lower the pressure to to maintain the same voltage, same lighting, to get the same lighting, we have to reduce this resistance. To what value? That again you can adjust the resistance and see with the variable resistance. So usually for 3 volt battery, for the same amount of milliampere and same brightness, then it will be 100 ohms. That and all you can practice and see on your own. Okay then, my dear children, my dear thinkers. So on this National Technology Day, let's all celebrate the most basic things in a most elaborated way, okay, in a detailed way. So that is how your mentor Srinivas will help you understand all that. Now today, after this, I am going to give them another most complicated, complex circuit to fabricate it in a simple way. Okay then, let's get back later. Happy National Technology Day. Enjoy that. But you need to know why we are celebrating National Technology Day on 11th May. What is the great significance of this day? This is another question for all of you. Bye-bye. Signing off, your science friend Srinivas from Tinker Master Srinivas from scientificstudent.com.